In example 12, we are going to further understand the sketching of some curves, but this time round I want us to look at a cubic function, and we are expected to talk about sketch the graph of y is equals to x minus 2 x plus 1, and we are expected again to sketch on the same set of axes the graph of y is equals to 2x minus 2, 2x plus 1, and b, the graph of y is equals to minus x minus 2, and x plus 1. Fine. Let us first of all have the original graph, but before we get there, we need to clearly outline our tool of Mayo. By now you are very familiar with Mayo, and I know that you are liking it. Minus a, 1 over a and a. Again, they should visit him. The first graph is the original graph, rather, x minus 2. Let us talk about the critical values. According to y is equals to x minus 2, x plus 1. But now it should be very automatic that the critical values are x is equals to 0, x is equals to 2, x is equals to negative 1. And we can easily plot them here. X is equals to negative 1, x is equals to 0, and x is equals to 2. But this one, we will have to apply the x tending to infinity method so that we can actually know the shape of our curve. And as x tends to be negative infinity, let's talk about negative 2. What do we have? X being negative 2, negative 2 minus 2, that is negative 4. The product there is already positive, and this being negative 2 plus 1 is negative 1, so the product will end up being negative. So as x tends to be negative infinity, y tends to be negative infinity. And as x tends to be positive infinity, let's talk about 3. This is 3 positive, 3 minus 2 positive, 3 plus 1 positive. So again, y tends to be infinity. So our graph, as x tends to be negative infinity, y negative infinity, x tends to be positive infinity, y positive. So our graph just looks like that. And this is the graph of, we can even talk about y is equals to fx, because this is original, but fx has a specific name. Y is equals to x minus 2, x plus 1. Now this graph is to be transformed to y is equals to 2x minus 2, 2x plus 1. And there is no problem as far as now this one is concerned, because you can clearly see that this graph has been multiplied by 2 throughout and inside. Every value of x has been multiplied by 2. Every value of x has been multiplied by 2. So this is multiplication inside. And as we know, and why are we calling it multiplication inside? Because 2 multiplies x, this 2 multiplies this x, 2 multiplies this x. So every value of x has been multiplied by 2. What does that mean? This means multiplication inside multiplication inside is a horizontal stretch of 1 over a steps. So multiplication inside is a horizontal stretch of 1 over of a scale factor which is a half. Horizontal stretch of half as a scale factor. That means what? All x values multiplied by a half, and we have seen this before. So if it is all x values multiplied by a half, then it follows that our new graph now takes a different shape. This is part A. Our new graph now comes over here, and we're going to have it like this. Here x was -1. -1 times a half is -1/2. Here x is 0. It doesn't change because 0 times a half remains 0. Here x was 2. 2 times a half is a 1. So you realize the shape of the graph doesn't change. So our new graph simply looks like that. And this is 1. So this is the graph of y is equals to 2x. 2x minus 2, 2x plus 1. It's multiplication inside, and you have seen it, which is now a horizontal stretch of a half. But let's go now to part B. Let's now go to part B. In part B, we are having something that looks like y is equals to minus x, x minus 2, x plus 1. You can already see this one has been multiplied. The difference between the original graph, which is here, and the graph we are expected to sketch is that there is a negative sign outside there. So there was a positive there. So this one has been multiplied by a -1, but outside, meaning what? Only this outer value of x has been affected. The rest of the values of x have not been affected. So it is outside. It is outside. And we're talking of what? This is multiplication outside, and according to my table, multiplication outside means vertical stretch of a step. This is vertical stretch of scale factor A. But what is our A? It is important to note that our A here is -1. So vertical stretch of scale factor -1. What does this mean? This means all y values, because if it's vertical, all y values multiplied by -1. X values do not change. So what kind of graph? We have talked about all y values multiplied by -1. So x values do not change. So what kind of a graph now do we acquire? Let's have it over here. Let's have it over there. So here, the value of y was positive whatever. Now the value of y is going to be negative whatever it was. At this particular point, the value of y is negative something times -1. The value of y becomes positive whatever it was here. Here, the value of y is at this particular point, the value of y is 0, so it remains -1 there. X do not change, and this particular point y remains 0. X do not change. This point x remains 2. X does not change. But of course, you could see the value of x here was negative, of y rather. The value of y was negative, let's say a. If it is -a times negative 1 becomes positive a. So it's like we are reflecting now this graph along the x-axis. So what was negative becomes positive. What was positive becomes negative. What was negative becomes positive. And what was positive here becomes negative. So our new graph takes a new shape that looks like that. And we can easily give it now its name as y is equals to minus x bracket x minus 2 x plus 1. Please note clearly that according to Mayo, multiplication outside means vertical stretch of scale factor a. It happens that our a was negative 1 there. That means multiply all y values by negative 1. And that is where we can see our original graph looks like it has been reflected along the x-axis simply because when we multiply all y values by negative 1, what was negative becomes positive, what was positive becomes negative, what was 0 remained 0. And that is it. So it is important to actually identify the real and the correct transformation. All right?